So moving forward with 11.2, and in fact, all of the sections 11.2, 11.3, and 11.4, we're going to be dealing with matrices. So this section, we're going to talk about matrices, and I'm going to show you a simple way of solving any type of system of equation. And then in 11.3, we're going to talk about a different way that's more algebraic that you can do by hand. Either of these ways work. Usually they do one before the other. Our book does this way before. And in fact, if you had friends that are in the honors algebra, they do all of this stuff that we're going to be doing by hand. So be thankful that we're skipping a bunch of information on solving these matrices by hand and just trusting that our calculator and computer can do all of these. So we start with the definition of a matrix. So a matrix is a set of numbers that are arranged in an array with digits that are in numbers and or rows, which are across. So across is rows and down is columns. So you might be asked, what is the value in row 3, column 2? So row 3, column 2 is R. So each letter in this matrix has a corresponding row and column. So we use matrices all of the time when we use computers. That's how we store information. They're stored in these vast, large systems and data sets of numbers. So what we're going to do is start off with really simple things, and we can build to more complex ones. So the first thing that we need to do is write the augmented matrix of each system of equations. So an augmented matrix takes the values of the coefficients times the variables equals the solutions. So I'll show you what I mean by that in just a second. So we are going to write the coefficients on the left side. So the coefficients 3, -4, 2, -3. xy, xy, times our column, so our variables, which are x and our y, and when we get to 11.4, we're going to talk about how we actually multiply these, equals -6, -5. So just kind of how it looks like our system. This is our augmented matrix. So oftentimes we're going to write this as A times B equals C. So with this augmented matrix, so we are going to take our coefficients, so 2, -1, -1, then we have 1. We don't have, this doesn't have a y there, so that's 0, 1, and we have to move this 1 to the other side because we just want our variables over. And then we have 1, 2, there's no z term, 0, and we're going to add 8. Add 8. So then our variables here are x, y, and z. And then this is equal to 0, which is our first, 1, which is our second, and 8, which is our third. So these two are examples of augmented matrices. Now, we can do all of the work and talk about reduced row echelon form and getting this to be all ones and zeros, which is what your calculator is going to do. And we could utilize reduced row echelon form to solve these. We are skipping that process. It is tedious. We can do it. If you want, ask me in class. I will show you how to do reduced row echelon form. In essence, what you're doing is you're converting this system into ones and zeros, which is solving the system. What we are going to do is if you can put this into the form A times B equals C, where A is the coefficient of the matrix of the variables, B is the variables themselves, and C is the solution or the answers on the other side. We're going to talk about a way to solve these systems. And when we flip it over, I'm going to show you exactly what we do and how to type it in. So starting with example 2, as we saw last chapter, if you want to solve this by hand, you can. It will take a little bit of work, maybe 5 minutes worth of algebra, and you could make mistakes. You don't have to. So what we're going to do is we're first going to write our A times B equals C. That's your first step. I'm going to write step 1. So then we're going to actually write it. So we're going to have our 3 by 3 because we have 3 variables here. So we have 2, 2, 0 because there's no Z, 1, 1, 1, and then 3, 4, negative 1. That's our A. Times X, Y, Z equals 6, 1, 13. So the way that we solve these with operations with matrices, there are ways you can add, subtract, and multiply, but there is no way to divide a matrix to the other side. How you undo a matrix, though, is multiplying both sides by its inverse. So if you do this, these cancel out, and we're left with B equals A inverse times C. The order is also important for how matrices work. So if we multiply by the inverse of A times C, we will get our solution. So take a look at your calculator, and I'm going to take mine right here, turn it on, and let's see if I can zoom in just a little bit. Okay, so this button right next to the 9, if you press that, you will see all of these different options. What I want is this one because I can type in exactly what I want. So if I hit enter, it's going to ask me the number of rows and the number of columns. I want a 3 by 3 for my first one, so I'm going to hit OK. I'm going to type in all of the numbers that we just wrote. So 2, 2, 0, 1, 1, 1, and then the last one, 3, 4, negative 1. Next up, we are going to hit the up arrow for exponents and write negative 1. Your calculator is smart enough to know that means inverse for matrices and not 1 over. We will do that in level 4. So then we're going to hit this button again, hit here, and now we want 3 rows by 1 column. And it should look like this, exactly how we set it up. And we're going to type in what we are equal to. Sorry, I had to slide so I could see that. It's 6, 1, 13. Once I hit enter, it's going to do this operation for me. And what I'm left with, and if I zoom out here, I'm left with 1, 2, negative 2. So what we just showed is x, y, z is equal to 1, 2, and negative 2. Or x equals 1, y equals 2, and z equals negative 2. So that's how you use your calculator to solve these systems super quickly. Now, the math behind these we will get to. But if you trust me that this voodoo algebra and this computer is solving everything for you, then this is going to make your life a whole lot easier. Okay, so what I require, you're going to write A times B equals C, and then you're going to write B equals A inverse times C. Those are the two things that you need to write first. And then we're going to write A is 1, negative 1, 1, 2, 3, negative 1, 3, negative 2, negative 9. Our B is X, Y, Z. And our C is 8, negative 2, 9. So once we get all that, let's pull out the calculator. Zoom in just for you guys. So we want a 3 by 3, and we're going to go 1, negative 1, 1, 2, 3, negative 1, 3, negative 2, negative 9. We're going to go caret, negative 1, times, then we're going to go 3 by 1 of 8, negative 2, 9. Double check to make sure that all of these numbers match our setup. Hit enter. You may get decimals. Mine's giving me fractions as answer. And what would have been atrocious to do by hand gives us a really simple way of writing this out. So I'm going to zoom out so you can kind of see that. So I have x equals 37 elevenths. Y equals negative 45 over 22. Z equals 57 over 22. You can do all of these by hand. I don't recommend you do them. This way is showing you a much more efficient way of solving them. Okay, if you don't believe me, try example 4 by hand. I will wait. And in fact, while you do that by hand, I will quietly write out what you do. So A times B equals C. B equals A inverse times C. We write our augmented matrix. So we have 1, 1, 1, 2, negative 1, negative 1, 1, 2, 2, times x, y, z equals 6, 3, 0. Once you do all that, we're going to calculator it up. I'm going to move this so I can see it. Button next to 9, 3 by 3, 1, 1, 1, 2, negative 1, negative 1, 1, 2, 2, inverse times 3 by 1, 6, 3, 0. Error. So when we do this one, this is saying it's an error. Why? Well, if we have a singular matrix, and if I zoom back out, then we have no solution. The crazy thing about all of these matrix and this solution is it doesn't matter how many equations we have and how many variables it has. As long as we have an equal number of equations to the number of variables, we can use these matrix calculations and this inverse solution to solve our system. So if we had an equation that was a system that was 100 equations and 100 variables, we could use a computer to solve these. And in fact, that's what they do. So this last question is just saying, let's extrapolate. Let's say we had 4 equations and 4 unknowns. Do you want to solve this by hand? We first have to get it down to 3 equations, 3 unknowns. Then we have to get it down to 2 equations and 2 unknowns. And then we would have to solve for 1 equation and then work our way back up. That's a lot of work. So instead, we can say A times B equals C, and then B equals A inverse times C. So then we write our A, which is our coefficients, 1, 1, 1, 1, negative 1, 2, 1, 0, 2, 3, 1, negative 1, and negative 2, 1, negative 2, 2, times x, y, z, w equals 4, 0, 6, negative 1. Now once you get all of that, you're done. You're going to write B equals, or x, y, z, w if you want, equals. And then we're just going to get our matrix solution. So let's jump to our calculator. Zoom in so you can see. So we have matrix button. We have a 4 by 4. Let's get that right. Now I just have to type in my information. So 1, 1, 1, 1. Negative 1, 2, 1, 0. 2, 3, negative 1. Sorry, 2, 3, 1, negative 1. And it's really important that we type in all of this correctly. So negative 2, 1, negative 2, 2. Inverse, so to the negative first power, times a 4 by 1, which is 4, 0, 6, negative 1. If we do all of that, our solutions to this, x is 2, y is 1, z is 0, and w is 1. So we have 2, 1, 0, 1. If you see, I've left you a little bit of space. Let me move my pen. I've left you a little bit of space. If you have any questions on what we did or what application you should be using, or if you don't have one of these graphing calculators, besides get one or borrow one, download the app. You have your phone, use it. It works pretty well. You need to get practice in setting these up and then being able to type them in. So today we're going to work on these problems, and then we're going to move on to 11.3, which is a different way of solving systems.